Okay. So in the last part you were thinking about factoring it, and you talked about the sums and the products of the roots.
So we factored it.
Or you tried to factor it.
This is really as far as you can get.
Yeah, but you did get, that helped you. You got something from that.
Yeah, a is an integer.
Okay.
So we know we have, I call the roots actually, I'm going to call the roots p and q.
Okay.
And we know that p plus q is a, and p times q is 2a.
Okay.
Well, there could be, maybe there's more than one value for p and q, but I'm not sure yet.
Well, the problem is certainly asking you to add up all the values of a for which this is true. So there probably, for any given value of a, there's probably only one set of p and q that makes this work. But for different a's, there probably are different p's and q's.
So, maybe you could solve this equation by saying p times q is 2p plus 2q. Because it's 2 times this.
Okay.
But then we have one equation and one variable. I mean, one equation and 2 variables.
Yeah. Yeah, that's true. So that's tough.
They're
Especially because we started with one variable.
Yeah. So maybe introducing all the p's and q's is a bad idea.
Okay. It seems to start making the problem more complicated. Now maybe there's something we could do with that. I'm not sure.
But where to go from here?
Yeah.
Well, if we could try to pick a value for a, and then find some roots that work. But
yeah, it's going to be tough. It's going to be tough to get some check on problem 23, especially because you're probably not going to have that whole ton of time left.
So what can we do here? Well, maybe we could use the quadratic formula to find the roots.
Ah, okay. So we have a quadratic equation. And we actually have two techniques for approaching quadratic equations. What are they?
Factoring it.
Oh, actually, you're right. We have three.
And the quadratic formula.
Factoring, quadratic formula, and we have one other important one.
Completing the square.
Completing the square.
But we're not sure if there's a square to complete.
Yeah. Okay, so quadratic formula.
Alright.
What does the quadratic formula say?
So it says, in this case, a plus or minus square root of a squared minus 8a over 2. And
Okay.
we
So
know,
those are the roots.
yeah. And this is an integer.
Yep.
So we need to figure out something to do with this.
Ah, okay. Good. What has to be true about that expression?
A squared minus 8a has to be a square.
Aha. High five. See, you are making progress through this problem. It's certainly not obvious that that's true from this equation and the fact that the roots are integers. But it pops out of the quadratic formula that now we have a squared minus 8a. It has to be a perfect square.
Well,
Write that down. A squared minus 8a is a perfect square. So what is the perfect square?
equals, it's going to be some number squared.
Okay. What do you want to call it?
I'll call it b.
B squared. A squared minus 8a equals b squared. Okay, great. On to part 3.